嗯呃，来自南曼大学的刘少宇院长，然后还有Dr Teoh，还有各位老师，校方的呃主任，还有同学们欢迎出席我们的全国中学生城市设计竞赛的线上工作坊啊。然后为期2天，就是27号、28号，就是今天会有早上一场，然后下午一场，然后礼拜天的下午一场。我稍微说明一下说，因为我们全国中学生城市设计竞赛的第一届到第3届的成果是像这个表列这样子，我们的女生人数也逐渐上升，还有初中的人数也逐渐上升。那第4届我们进步的地方呢，是我们有正式向马来西亚的教育局、州教育局和县教育局提出活动的申请，也得到批准跟推广啦。那再来的话，就是我们也把自学平台的成绩也当成我们的资格考。那截至现在为止，大概有超过60%的同学已经通过资格考了。那在这个基础上呢，我们还想做一点点，例如说现在最热门的就是大语言模型 AI 嘛，那再加上去年我们开始推广 SDG，联合国的 SDG，我们也试着希望解决现实生活的难题，还有把它变成一个竞赛的方式。那基于这4点的话，我们诞生了这一次的竞赛，也就是 AI versus 的 SDG 跟 Hackathon 的 competition 哦。那呃我们邀请我们的国立台湾大学马来西亚校友会的赵建强会长帮我们做一个欢迎词。
好，谢谢世萌大家早上好。我们现场的有南门大学资讯通讯与电脑科技学院的院长刘少仪教授，然后还有 Dr. Teoh，还有 Alex 我们下午的讲师 Dr. Alex Ray，还有我们明天的那个那个 domain 的 expert 张庭忠同学，各位老师、各位同学，各位台大校友大家早上好，感谢大家参加今天的工作坊。刚才秘书有介绍，过去我们几年都是有办了十几场的那个工作坊，然后我看参与的同学很多很熟悉的一个名字，也谢谢同学们在我们学到城市设计的一些技巧之后，来尝试解决一些现实上的问题了。So 加上呢，去年那个 ChatGPT 的横空出世那我们以拉曼的团队也商讨了，便接续来设计这个 AI 与 SDG 的黑客松比赛。那由于我们都是第一次在做那这个比赛呢都是实验性质比较高。那我们将会在就是雪隆举办一场，如果效果良好，才会到全国各地去分开举行。那什么是黑客松？相信同学们都有所了解那目前呢，那个黑客松比赛主要都是由大学或者是企业主办给大学生和企业的员工来参加了，让背景不同、技术不同的开发者在限定的时间内编程开发，创造产品的原型提出最佳的解决方案。其实我们也非常担心这种比赛，中学生会不会有足够的知识储备来参加，会不会难倒同学和老师不过我们可以尝试看看，便知道结果如何。所以在比赛之前，我们安排了今天跟明天的2个工作坊分别由拉曼的教授还有行业的专家来介绍工具的使用和比赛的相关背景当然这2天我们也不会公布那个比赛的题目了 那今天早上将会由 Dr. Teoh 来指导这个大型语言模型 LM 的现在和未来。下午呢，这由 Dr. Alex Wei 教导如何使用 ChatGPT 的 API 如何问问题等。另外，明天的工作坊是由我们台大的优秀校友张庭忠先生介绍比赛相关题目的背景知识。那这个实验性的比赛对教授、中学老师、同学们是个挑战。不管结果如何了，我们都抱着学习的态度来比赛，相信让学生在中学时期尝试理解跟提出解决方案之后，不管在升学或者是就业，都具备了解决问题的高度能力和与人合作的优异条件。听完这个讲座请同学有兴趣同学可以踊跃报名参加，也介绍老师，也介绍其他同学一起来参与，大家一同学习。好，谢谢大家。
谢谢我们
教会给
的
世盟。
OK。好，谢谢我们的赵建强会长。那个诚如会长讲的一样，就是我们的总共3场的工作坊，时间就是分别今天早上的上午跟今天的下午，还有明天的下午的时段，分别由我们的拉曼大学团队，还有我们的张庭忠学长来做呈现。那我们的 Zoom 呢是一样的，就是3场的 Zoom 都是同一个 ID 跟 passcode。所以同学就是有收到的，就是登录在相关的时段，登录那个 Zoom 的 ID 就可以连线了。那我们就直接邀请我们今天上午的讲师，也就是我们的来自拉曼大学的 Dr. Teoh， 他会讲大语言模型的现在跟未来Dr. Teoh 也是在机器学习跟机器视觉变呈现，还有深度学习上有非常的深入的策略啦，然后跟研究。那我们就邀请我们的Dr. Teoh 帮我们做今天上午的工作坊。
好谢谢。给我 share 我的 screen 先。
OK，可以看得到，
看得到吗
看得到，
？OK，各位早上好，OK，我是来自拉曼大学的Dr. Teoh，如果随意一点的话，可以叫我 John Teoh。OK，所以说我在这个教书呢已经有超过14年了，多数都是在做研究在这些 AI、computer vision、embedded system 的一些东西，这个是一点点我 about myself 啦。OK，所以说等下的讲解会用英文，OK，不过大家有什么疑问的话，你们都可以用华语来问问题，或者在 chat 那边问问题，我也是可以用华语来回答你们。OK，所以说现在呢，我们就直接开始吧。好，OK，so good morning everyone. Okay, so before we start, right? Okay, let me do a little bit. Let me turn off my camera so that you can have a good connections. Okay, so before we restart, let's do a little bit of interactions sections. Okay, it's a morning now. Okay, let's do a little bit of interactions. So just want to get a little bit of knowing you. Okay, how much you have know about AI. Sorry, for today, the workshop is progress and future trend of large language model, right? So before we really go into large language model, so the fundamental knowledge it should be you need to know what's AI first. Okay, before you really go to what is large language model. Okay, so step by step. So today we'll go through what is AI, then talk about a little bit about the machine learning and also deep learning. Okay, and then I will do about a short demo of how the machine learning in actions. Okay, there's some codings to show you just a little bit short demo so that you know that this is what is happening behind the scene, because now we actually use AI a lot, but what is happening behind the scenes? So today I will show you for that, and then we only go to large language model. Okay, how it works, what is it, and how it works. Okay, so again, before we go into my slide, okay, so let's say I want to do some interactions sections. So I want to know how much you have know about AI, how many times you have used AI, so on and so forth. Okay, so just a short introduction. So I just need a few things only. Okay, let me just put up my slide. Okay, so let me just put on present. Okay, just a simple 3 questions only, just so that I know what is you're expecting from this workshop, so I can tune my workshop. Okay, so first of all, what you should do is you can use your phone. Okay, open a browser, use a phone, open a browser, and then or you can use the laptop in front of you as well. Okay, just open a browser and go to this main.d. Okay, just need to type main.d.com. Then it will straight away ask you what is your code. Okay, what's the code? Just need to type in this code. Okay, and then it will straight away prompt you this. Oh, so fast. Okay, someone already go in. Okay, yeah. So once you're going, okay, you can straight away see this question already, and with these four answer. I mean 4 options. Okay, you just need to pick one and click submit. Then I straight away can see the result already. Okay, so I can see. Oh, now one is yes. Okay, you are familiar yourself. Okay, with AI already. Okay, then have 3 of you. It's like kinda not so much. Okay. Okay, how about others? So we have 36, 37 of participants now. Okay, so where do we answer this? Okay, let me just need to go to bendy.com and just type in the chat. Okay, and then use the code 65562560. Okay, so yeah, maybe one or 2 minutes. Okay, then I will go to the next slide. So for the first question is, I'm familiar with the concept of AI. Okay, so we have 4 options here. Yes, I know the concept already. And then second is kinda, third is not so much, then fourth one is no. Okay, so much. So we have lot portion of kinda. Okay. Okay, anyone else? Before I go to the next questions, well, I will only prepare 3 questions just to do some interaction with you. Okay, the first one is that this screen in front of you, I'm familiar with the concept of AI. So we have 3 of them is yes. Okay, good. Then we have 12 of you are kinda, then 3 is not so much, and 1 is no. Okay, so are we good? So we just go to the next questions. Okay, so next questions. Okay, so I have experience in applying the AI algorithm in my projects. And in any projects you have done before, you have experience already. Okay, well, it's I already have the experience. Okay, apply AI algorithm like face detections, predict stock market, predict whether it's rain or not, predict whether that pictures is a dog or cat, something like that. Okay, that's AI algorithm. Okay. Oh, most of you already have some experience. Okay, good. And then I have 3 of you, not so much 4. No, it's 3. Okay, so kind of like balance, okay, for this. Okay, anyone else? Okay, so let's go to the last one. Okay, I've used the large language model, okay, to solve my problem. Okay, large language model, as you already know, ChatGPT, one of them. Then we have Bard, Copilots. These are all large language model. I think most of you have used before lah. Okay, for now. Okay, most of you are yes, have used it before. Okay, use it to solve your problem. For example, give you some ideas how to start something. Okay, how about others? Anyone else? Some are yes, some of them is no. It's okay to have if you didn't use before, because later in the afternoons you will definitely know how to use it already, because Dr. Alex will teach you how to use it. Okay, that's good. We have a lot of you already know how to use, have used the LLM to solve your problem. Okay, so that's just a short introduction. So I know that more close with you. So I know that some of you have experience in using AI. Okay, if those already have experience, you can treat this workshop as revisions, or maybe something that you didn't know you can get from this workshop. Some of you didn't have any concept of AI. It's okay. This workshop is for you. And then you have whether you have used AI in your project. So today I will go through some of them. Then I will do some demo. Okay, mainly using Python to show you some demo, what's happened behind the scenes. And also, yeah, that's for today's workshop. So step by step, start with AI, machine learning, deep learning, and large language model. Okay, so a little bit of them, okay, because 3 hours definitely cannot go very in depth. Okay, so that's why I will go through a little bit of them so that you can have a broad idea, okay, from AI, machine learning, deep learning, and lastly, large language model. Okay, that's good. Thank you for these interactions. So let me just move this away. Okay. All right, so let's get started. Okay, so yeah, let's get started. Okay, so as you all know that now we are living in the world of humans and machines. Okay, so the humans has been evolving and learning from the past experience since like millions years ago. Okay, so on the other hand, the era of machines and robots has just begun. Okay, so in today's world, these machines or the robots, unlike they need to be programmed before they actually follow your instruction, right? But what if the machines start to learn on their own? And this is where the AI come into pictures. Okay, they are evolving. So this moving on, let's see the biggest confusions. You heard about AI, machine learning, deep learning, but are these the same or not? Okay, so maybe if you only have a general idea, maybe you think that they are the same. Okay, of course, there are some certain points they are the same now, okay, but there are certain points they are not the same. Okay, so let me just go through of them. Okay, so AI is a broader concept of machines being able to carry your tasks in a smart way. Okay, it covers anything which enable the computer to behave like humans. That's AI. Okay, so machine learning, okay, is subset of AI. Okay, but you can see it from this picture. So machine subset of AI is based on the idea that we should be able to give the machine the access to data. Okay, the access to data and let them learn from themselves. Okay, so like I said, it's a subset of AI that deal with the extraction of pattern from data set. Okay, so this means that the machine not only can find the rules for optimal behavior, but also can adapt to the changes in the world. Okay, so for deep learning is more a subset of machine learning, okay, where the machine learning algorithms are used to train deep neural network. So the keywords for deep learning is neural network. Okay, so what is that? That will explain. Okay, so with this deep neural network, so that it can actually achieve better accuracy in those cases that machine learning algorithm cannot afford to solve it. Okay, so that's a AI, machine learning, and deep learning. Okay, so yeah, so let's say they are the same. Some of point they are not the same. Okay, so that's now let's go to like the definitions of AI. Okay, AI have a lot of definitions. If you search in the internet, okay, I just pick those easy to understand one. Okay, so what is AI? Artificial intelligence. So it's a science of making machine that can think like human. Okay, that is AI. Okay, it can do things like they are considered smart. So AI technology can process large amount of data. So the goal of AI is able to do things such as recognize pattern, okay, make decisions and judges like humans. That's a broad idea of AI. Okay, so moving on, machine learning is a subset of AI, right? So it focuses mainly on designing of system, thereby allowing them to learn and make predictions based on some experience within data in case of machines. Okay, so machine learning is a core of many futuristics technologies advancing in our world. Okay, today you can see some examples that implement this machine learning, such as self-driving car, okay, face detections, face recognitions. Those are machine learning or maybe part of the AI as well. Okay, so machine learning also enable computer to act and make data-driven decision. Okay, rather than being just explicitly just program them to carry out a certain task. Okay, so these programs are designed to learn and improve over time when exposed to more and more new data. Okay, that's machine learning, keep on learning. Okay, and then deep learning. Okay, deep learning is a subset of machine learning that use multi-layer neural network. Okay, called deep neural network. So what is neural network? It's like our brain. I mean, it act out like our brain. Okay, they actually mimic our brain. Okay, later I'll explain it. Okay, so this deep neural network is simulate simulate the complex decision power making power of the human brain. Okay, so deep learning is as an aspect of data science that driven many applications and services that improve the automations like as I say automation, performing analytics, and also physical tasks without human interventions. Okay, so this has enabled many everyday products and services such as digital assistant, okay, the chatbot, okay, voice-enabled TV remote. So a lot of things that you have voice control already, like the Alexa, okay, there's the Google, that's right, there's a voice-enabled system, okay, and then of course self-driving car also part of using the deep learning as well. Okay, of course generative AI and also large language model. Okay, these are based on deep learning. Okay, so that's concept of AI, machine learning, and deep learning. Okay, so now let's just go into some vocabulary. Okay, some comparison. Okay, if you didn't use AI before, okay, and you actually now still using traditional programming, what's the difference between traditional programming and machine learning? Can you use traditional programming to predict something? Okay, so from here, let's just go through. We just go through about this. Okay, so from here you can see that for traditional programming, let me bring out my laser. Okay, for traditional programming, usually is what you have prepared for the predictions. Okay, usually you just give in the input. You have a program, then it will just give you output. Input is the input, and then program is the C++ file, Java file, Python file. Okay, put into this, then it will give you output. That's it. That's for traditional programming. Okay, but for machine learning is a paradigm of approximating a function from data. Use data to give you a function. Okay, depends on data. Okay, to give you a function. So the function here is just a set of rules that make in like use the input and actually split out something like a label or predicted value. Label, for example, like whether it's cat or not cat. Predicted value, whether it's what is the value? Predicted value is like a number. Okay, predict a number. Okay, so why machine learning instead of programming? Why want to use machine learning instead of programming function ourselves? Because sometimes we can't possibly understand the pattern in our data. So if you didn't understand pattern, you cannot come out with rules. Okay, so yeah. So machine learning is fundamental fundamentally the process of allowing our data to give you, to guide functions creations. So what it means by this, for example, I give you an example. Let's say you have a pictures here. Okay, so this pictures is number 8. Okay, just for example, is number 8. So can you just use traditional programming to actually classify this picture is an 8 or not? Yes, actually, yes, you can do that. Okay, so how do you do that? Okay, just to let you know that the numbers 8 here, they are all pixels. Okay, you can use programming methods, traditional programming methods, to go through every pixel of them and try to figure out the pattern. Okay, it's possible. I mean, it's possible, just that it's very tedious because this is just one picture. How about if you have other pictures as well? Okay, so if you're using traditional programming, is quite hardcore. You need to hard-code a lot of things. Okay, why not use machine learning to help you to classify whether this is what's this picture about, whether it's digit 8, whether it's digit 9 or something like that. Okay, so okay, for this, right, traditional programming and also some algorithm are actually not really suitable for solving this problem. So how do you accomplish this? Okay, so you can use machine learning to find a generalization trend or pattern among these pixels. Okay, for example, the number 8 here. Okay, some of the things that the other image don't have. So you can draw a line to separate them. Okay, so these are the one of pattern. This is also another pattern as well. So you can draw a line. Okay, find this line is the functions to draw. Find this function to actually separate them so that later your machine learning code can actually classify them. This is 8, and this is 7, this, so on and so forth. Okay, so like I say, maybe the pixel value in the image of 8 have some correlation that other don't have because there's a curve here, something like that. Okay, maybe in some high dimensional space, there are some things that they are separate from each other. Okay, so yeah, this is how do you write functions, okay, in machine learning to classify them. Okay, so to narrowing what is in the machine learning, right? So the art of this machine learning is as following. So what form our function takes? Okay, this can be referred to as a class of model. Okay, what specific parts of this function will be allowed to learn? Okay, which specific parts? This called parameter. Okay, then how we learn from this parameter to approximate the best possible value. That's the art of machine learning. Okay, so for every machine learning algorithm you will ever learn, right, follow this pattern as well. First of all, describe the general form of function with 3 parameters. Use data to decide what those 3 parameters will work the best. Okay, so for this one, right, we have some vocabulary. If you deal with AI will be some vocabulary. These are some vocabulary. So all these vocabulary have different kind of meanings. Okay, but I'll just pick those easy to understand one. Okay, these are the statement. First of all, function. If you deal with AI, machine learning, deep learning, okay, you heard about function. Maybe you more actually heard about its model. Okay, just now I mentioned large language model. You can see there's a model behind, right? AI model, machine learning model, deep learning model. So this model is inside what's behind the scene is all function. Okay, it's a program that can find pattern or make decision from the previously unseen data set. Okay, that's a model. And then for parameters, it's a term used to denote the parameters in machine learning model that can learn from data. These are parameters. Then we have hyperparameters as well. Okay, this is some external configurations variable used to manage the machine learning model training. You can tune this parameter so that it can achieve the best result. And then we have a loss function. These are the vocabulary. Loss function is a manipulative function that quantifies the difference between predicted and actual value. So because we are using machine learning or deep learning, any AI model to predict something, right? If you predict things, and then you must compare with the actual value. If they are not the same, then we try to tune the parameters and tune the hyperparameters so that at the end, your machine learning model can increase the accuracy of your machine learning model. So we need some loss function to help us know that how well is our machine learning model. Okay, lastly, is a feature. It's the things that you extract from maybe from a picture, from dumb data. These are all features. Okay, so moving on, the machine learning pipeline. Okay, not about machine learning pipeline like AI pipeline, deep learning pipeline, they all work the same. So what is the start? What is the end? When you work with some AI project or machine learning project or deep learning project, right? So you should start with, you basically follow this pipeline. Okay, first of all, you have problem. Okay, after you have problem, you want to predict something, you must give them the data. Okay, you have a data. Okay, second is prepare data. And then based on this data, based on the problem, you must have experience, you must have the ability to actually define the model, which means that choose the correct model for your problem and for your data. If you choose the wrong model, it may not have a very good result. Okay, after you have defined the model, then define loss function as well. Okay, again, in the world, we have a lot of loss function. Okay, so you must have a good, find out what is a good loss function so that it can actually suit your model. So just for example, if you cannot pick those, if your model is a classification, you cannot pick those loss function is to evaluate a number. Okay, classification and number, they are different things. Okay, so yeah. Then number 4 is minimize the loss function. Okay, this is what I mean, train the model. Okay, after you train the model, test it, you've certified the result, then you're done. Okay, let's go through one by one. Okay, let's talk about this. Okay, let's go through one by one. So first of all, define your problem. Okay, so if you have a problem, then you may think that what is your input look like? Whether then this means your data. So first of all, your data can have 3 types of them. First of all, structured data. Structured data, which means that they are all in structure, which is all the data, they are in the table form. Excel files, those kind of things, they are in the table form. Everything is organized nicely for you. This is called structured data. Semi-structured data. So for example, it's like the things like in CSV file, email, those are semi-structured data. Lastly, unstructured data, which is the data in the form of audio, image, video. These are unstructured data. Okay, so next thing about what are you trying to do? Is this a supervised learning, unsupervised learning, or reinforcement learning? Okay, today I will talk about supervised and unsupervised learning later. Okay, after that, what is the metrics for success of a project level? Which means that what is the metrics you want to measure? You want to evaluate your model, whether have a very good accuracy, whether it's robust to unseen data. Okay, that's first thing, define the problem. Next, prepare the data. Okay, data preparation. So machine learning, AI, okay, machine learning, deep learning, these always start with data. If you don't have data, end of story. Okay, so if you have data, make sure your data is good and legit. Okay, so yeah, as I say, first of all, collecting the data. Okay, data, sometimes data collection is not, you cannot be taken for granted. Okay, because sometimes data is not there, you must go and collect yourself. Okay, so why this is very important? Because if you use a bad data to do the training, then you will lead to bad result. Okay, because the data is not relevant to your problem. Then you use it to do the training, then at the end you get a bad result. Okay, so next, this data need to be represented in numbers. So as you can see, the model, what's happening behind the model is a function. What's a function? Function is some mathematical form. So they are all in numbers. So you must find a way how to change text to numbers, image files to numbers as well. Okay, you must prepare in numbers, and then feature selection. So how do you extract features? There will be another course already. Okay, how do you extract features? There are a lot of mathematical forms. How do you extract features? For example, finding which parts of data are important and should be included as input to your model. Okay, then you may want to rescale some features so that they're in the same range of values. So this is called normalizations. Okay, lastly, the vectors are one of the most basic and important representative of data. Okay, basically you want to make the important numbers and put them in 1D matrix. Okay, this is especially true when in deep learning. Okay, you want to make in 1D so that your deep learning can learn well. Okay, so after you have prepared data, then you go to partition. Okay, partition the data, because you want to train the model, right? You must have different set of data so that it can make your model more generalized. Okay, generalized to data. Okay, so what is meant by this is you want to see how well the model perform on data they haven't seen before. Okay, because for any machine learning or deep learning, okay, if your model only train at the data this they have been seen before, they have seen before. Okay, then no point because they haven't learned from this data. If you give the new data to this model, and then your model is not able to perform, then it's not that good. Okay, so I say machine learning is useless unless it can work with a new data in the real world. Because in the real world, it's always happening, so it always have new data. So your model must be good in working with your new data. Okay, so set aside a specific data to test the generalization. That is the data the model haven't seen before. So for this case, if you have the data, okay, how do you split them? So usually it will follow these three data. It may be different, okay, depends on what you have want to solve. So first of all, it must have training data used for optimizing the parameter, which means that this data will use for training. And then we have validation data used to diagnose the training stage. Lastly, the testing data. This data is the one that the model didn't see before. So you can evaluate how well the model work with the unseen data. Okay, these are some concepts. Okay, so you want to make your model, if you're dealing with AI project, you want to make your model robust. Okay, these are the steps that may help you. Okay, after you have partition data, then define the model. So there are a lot of models, there are a lot of algorithms there. Okay, you can be your own model as well. Okay, then if not, you can just based on your problem, you can find those models that is suitable for your project. Okay, so which model can be used to solve the machine problem? Okay, some modeling techniques only work for very specific tasks. For example, we have some machine model here, linear regressions. KN, K means clustering. Which one is better for your project, for your problem? So you need to have some experience to choose which model is suitable for your problem. Okay, so I say which model can best capture the structure of your data. Okay, so take note that what your model output should look like. Is it a single value, multiple value? Is it an image? Okay, so you can actually train different model. Okay, so like I said, machine learning model have a lot of them. Okay, if you think that these three are the potential model, you can actually train all of them and see what's the result and pick the best one. Okay, that's a defined model. Lastly, define the loss. Okay, so you can learn an optimal selection of parameters here. There are some metrics to optimize. So different model will have different way of learning specific parameters. Not all of them will use the same things. Okay, so once you have the model and your data, your job will be to minimize a loss function. So there are a lot of ways to optimize it to minimize the loss function. That's your main job as an AI. Let's say in the future you want to be an AI engineer. That's the main thing. You want to minimize the loss function, which is minimize the error and increase the accuracy. Okay, so these are some examples. If you are using supervised learning and it's a linear regression, this will be the state-of-the-art metrics for you to evaluate your model. Okay, just for example, you have mean absolute error and mean square error, just for example. And then, by now you have data, you have model, you have loss function selected already, then it's time to train the model. Okay, so this is a phase that you apply different algorithm or to select the best parameters, train the model very well. Okay, so train the model is as in to fit the best combination of weight and bias. Okay, weight and bias, maybe I will explain it later. Okay, so to the machine learning algorithm to minimize the loss function over the prediction stage. So different model have different training procedure. Okay, it's fun to work on this because different model have different training procedure. So yeah, it's fun to work on it. Okay, after training, lastly is the finishing step. So you want to test your model performance. Okay, whether it's good. Okay, in training data. Okay, yeah, if you are using the training data, test your model, they actually work very well. Okay, but if the model didn't see before, you say that no, the model cannot work. Okay, it may happen. Okay, based on my experience, it may happen. Okay, so you want to make sure your model can be more generalized to those unseen data. Okay, so there's some trade-off between accuracy and generalizations. Sometimes if the model make more complex, it might be able to learn more complex pattern. Okay, but we also have a risk to simply memorizing the training data because you only train on training data, this training data only. So the model may be more biased to this training data. Okay, instead of learning anything else. Okay, so yeah, these are the step. Okay, pipeline, machine learning pipeline. Okay, not about machine learning. Deep learning also follow the same pipeline. Same start with define the problem, data, then training, and come to result. These are all the standard SOP, I say SOP. Okay, when you're dealing with AI project. So in the nutshell, how the machine learning work. Okay, this summarize everything. Okay, so from here, one of the methods, from here you can see that machine is trained using a label or unlabeled data. Train the data set to produce a model. Again, new, from here you can see that new input data is introduced to the machine learning algorithm, and it will make prediction based on this model. And then the predictions is evaluated for accuracy. And if the accuracy is accepted, then the machine learning algorithm is deployed. Okay, however, if the accuracy is not very good, then the machine learning is to train again and again with the more training data set. Okay, so from here, training data set, go into the training, the machine learning model, and then you have this model already, then you put in the new input to test it, okay, then to see whether it's good or not. If it's not good, train again. If it's good, then you have your successful model. Okay, so these are the step-by-step, okay, some instructions of this step-by-step, how do you make your machine learning model work. Okay, so let's go to non-very technical things. Okay, so where can you find the machine learning? Okay, application of machine learning. Just give us some examples. Okay, for example, Google Maps. Okay, this part. I mean, if you use GPS based or Google Map before, so the price of you can see that there are a lot of traffic here. Okay, so if you're using this Google Map, it have some algorithm behind. Okay, so no matter what, if there's a traffic or not, you will be always on the fastest route. Okay, based on the data collected from this Google Map, you always be the fastest route. Okay, again, how the Google Map know that whether this is congested or not is actually based on you to contribute whether that area is congested or not. So from there, Google actually take all this input data and then give you the fastest route. Okay, that's what's the next example is the traffic recommendations. Okay, so this is one of the example like Alibaba Cloud. Okay, they actually partner with Hangzhou's to deploy a smart city management system able to predict or provide you a real-time traffic recommendation and travel routes. One of the example, and then computer vision's algorithm also part of the machine learning. Okay, so for this is a Land Transport Authority of the Singapore actually use this is a drone view. Okay, to detect what's the traffic in that particular area, and then give you a recommendation whether to avoid the area or not. Okay, so these are some applications of this machine learning. So just now I mentioned machine learning have supervised learning and supervised learning, and also reinforcement learning, right? So for this case, I will just focus on this supervised learning and unsupervised learning. So I'll give you a general idea only lah. Okay, they didn't go very in depth like what's mathematics used in the supervised and unsupervised learning. Okay, so I'll give you a general idea. So if you want to know more, you can go in depth about it based on the general idea I give you. Okay, so for supervised learning, okay, so this is the mathematics. Just give you some mathematics definition of this supervised learning. Okay, so supervised learning is the one that where you have the input variable x here, okay, and the output variable y. Okay, and you use the algorithm, which is functions here, to learn the mapping from input to output. How do you map from input to output? It's based on this function, on this model here. Okay, so the objective is to tune the algorithm so well that wherever you get the new input of x, the machine can easily predict the output of y. So you must tune the x here, the function here well. Okay, so if it's kind of confusing, let me just rephrase with the simple terms. Okay, so in the supervised machine learning algorithm, okay, every instance of the training data set consists of input attribute, and this is called input attribute, and also this is the output. Okay, expected output. Okay, so the training data set can take any kind of data as input, like the values from the database, okay, the pixel of the image, or even the audio frequency histogram. That's anything can be the input. And then each input instance is associated with the expected output. Okay, so you already have a sample. You have an input. Based on this input and what is the output. Okay, you already have this data. Okay, so the algorithm will learn from this data and to predict the output for you. So it will train from this data. So once the algorithm is trained, it will be used to predict the correct output that never seen before. Okay, so from here you can see there's Apple here. We have Apple. Okay, then they have a lot of algorithm happening in the model training. Okay, we have supervisor, they have training set, then what is the desired output? Pick the correct model, machine learning model, and do some processing. And then after you have trained it, you've got your model already. And then like if you put the new input to it, then this model will use some mathematics form to predict whether this is Apple or not. Okay, that's supervised learning. What is mean? Okay, now you already know that the word supervised because you are the one that supervise. Okay, supervise this model to learn from input to output. You actually supervise them because the data already from the data, right? You have input and output, right? So that is the data already. You already know what is the output. So you actually supervise the model to learn based on input to predict the output. Okay, you actually supervise the model. So that's why it's called supervised learning. Okay, and then we have another, just give you another example. So let's say you have the pictures over here. Okay, pictures here, you have cat and not cat. Okay, these are cats. Okay, then these are not cat. But this one, you know, this dog, but I just label it as not a cat. So for this case, these are the data. Okay, these are data. This picture, you know that this is a cat. This is the input X. Cat is a Y output. So we have X and Y together. It's a pair, always a pair. So all these were put into the supervised learning. Okay, use supervised learning to predict, to form the predictive model. Okay, after you have trained it, after you have certified with this model, and then the next time you put another picture. For example, you put another picture, you can see that this picture, this cat is not in this data. It's not from this data. Okay, if you put this picture into this predictive model, it straight away tell you that this is a cat, something like that. Okay, so this is another example. Okay, so the definitions of supervised learning can have a lot of things. Okay, so in supervised learning, the machine learn under supervision. You are the one that supervises the learning. Okay, it contains a model that is able to predict with the help of label dataset. Okay, label dataset, that's the vocabulary. Okay, what's meant by label dataset? Just already say that this is the label dataset, which means that this input already have a label, which is cat. It's called label dataset. Okay, every input or it has its label. Okay, every of that it has a label. This is called label dataset. Okay, so a label dataset is where you already know the target answer. You already know the answer. Okay, so this is the definition of supervised learning. Okay, so I'm not in full screen now. Okay, if you have any question, you can always ask in the chat. I will check the chat from time to time. Okay. Okay, so let's move on to see the under the supervised learning type, right? Okay, we have two of them. One is called classification. Okay, where the output variable is categorical, which is we have two or more classes. For example, the classes here is yes and no, true or false, cat and not a cat. These are categorical classes. Categorical. The output is categorical because it's called classification. We also have regressions. Regression is relationship between two or more variables. Okay, where the change in one variable will associate with the change in another variable, which means that regression is to predict a number. For example, stock market, you can use regression based on all the inputs. You can predict what's the stock market value, something like that. Okay, you can predict something in a value form. Okay, so again, I will not go into detail what's mathematical forms for that. Okay, maybe if you are going to mathematical form, you may feel boring. Okay, so I'll just give you a higher idea. What applications they actually use the classification and what's the application that use the regressions. Okay, so classifications you can use to classify a lot of things. Okay, so this is just one of example. It's called spam mail. Okay, if you notice your any email, okay, your Gmail, Hotmail, Yahoo, something like that. Okay, you can see that sometimes when the email comes into your inbox, right, it will sometimes go into spam. it will go to promotions, it go to social, something like that. Then how does it know? Okay, how does it know? Okay, so this one just give us an example. Okay, so from here you can see that to predict whether an email is spam or not. Okay, first we need to teach. If you want to build a if you want to build your own machine learning model to predict whether the email is a spam or not. Okay, so like I say, first we need to teach our model what a spam email look like. Okay, you need to teach the model, come and learn. Okay, what is this spam email look like? Okay, so maybe this spam email, okay, you can actually review the content, okay, content of the email, review the email header, okay, and it also search for any like falsified information as well. These are the input, these are features you can actually extract from those spam email and teach the model, this is the spam email. Okay, this is spam email or not a spam email. Okay, after that, you can generate blacklist filter to stop emails that come from already blacklisted known spammer as well. So all these filter, this can be like put into like one is called filter score. Okay, how do you filter score, or maybe the spam score? Okay, from here you can predict if it's higher the score means that will be the spam email as well. So from here you can see that if you already train the model, when there's a new email coming, okay, when there's new email coming, so the model will start to scan the content, email header, content, something like that. And then from here, it will predict whether it's not spam and spam. It's a categorical separation. You can use a model to predict that email based on the features that I already mentioned, the header, email header, the content, or anything other features, okay, so that the model will know that whether this is spam or not spam. Okay, this is one of the classifications example. Okay, so for regressions, okay, again, regression is to predict a number. Okay, just is to predict a number, right? So for this case, is weather predictions. Okay, you can predict the weather, okay, to predict the temperatures or humidity for that particular time. What is the forecasted humidity and temperature for that particular time? Okay, you can use the past data from here, the past data here, then use the regression model to learn from the past data and then do the predictions. Okay, so you can actually use this past data to fit into the regression model here, and then based on from this case, it's actually based on temperature and predict the humidity. Okay, so based on the past data, you already have a set of this. When you have this temperature, this is the humidity. When you have this temperature, this is the humidity. So for example, as the temperature increase, the humidity will decrease. So they are actually correlated with each other. So that's why you have an X here is the temperature, Y as an output is the humidity. So they are all in number. Okay, you can pick any regression model to learn from this temperature again and predict what is the humidity. Okay, so as a summary, regression is to predict a number, any number. Okay, so for example, like I say, you want to predict, for example, this amount of saving you have done. Okay, so based on this data, what will be your return? Something like that. You can do that as well. Okay, by using regression methods. Okay, so where is the application of supervised learning? Okay, just give you some examples. Okay, so first of all, you actually apply in risk management assessment to assess the risk in the financial services or an insurance domain to minimize the risk of portfolio of the company. Okay, you can use the supervised learning in image classification. So, just for example, Facebook actually recognize your friend in the picture from the album of a tag photo. So if you got used it before, once you upload the pictures to the Facebook, right, it asks you whether you want to tag this person or not. Okay, then this person, the Facebook somehow you already know that who is this person already. Yeah, this is some of the supervised learning lah. Okay, and then we have the fraud detection as well. Okay, to detect whether the transaction made by the user are authenticate or not. Okay, and lastly, the visual recognition. Okay, to identify the object, places, people, and actions. Okay, just a simple example of where it actually apply the supervised learning, the application of supervised learning. Okay, so yeah, that's all for supervised learning. Again, you can just give you an idea lah. Okay, I say like today like crash course, so this give you an idea what supervised learning. Okay, so let's go to unsupervised learning. Okay, so what is meant by unsupervised learning? Okay, so for this case, the general idea of unsupervised learning is you have the input of X. Okay, you have input of X and there's no Y. There's no output. That's unsupervised learning, which means that you have data, a lot of data in front of you, okay, but you don't know what is the output. You as self is as self, we as self as a human, we also don't know what's the output. So that's why we don't rely on this algorithm, unsupervised learning algorithm, to help you to make some insight, make some how to say, give you some hints, okay, from this data, what is this mean? Okay, what can you get from this data? You can use our algorithm to help you. Okay, so this is an example. Just give us an example. Okay, just assume that you don't know this is apple. Okay, this is a banana and this is a mango. Just assume you don't know. Okay, so in the unsupervised learning approach, right? Okay, the data instance of the training data set do not have the output. Let's say this is a red object, okay, yellow color object, and orange color object. Okay, just I said just predict, you don't know what is it lah. Okay, so do you have a red color object, yellow color object, and also orange color object? So these are the data instance that do not have the output. Okay, they do not have any output. This not this apple, this not banana, so on. Okay, they do not have any output. Okay, so they do not have the, like I said, they do not have the output associated to them. Okay, so instead, unsupervised learning algorithm is used to detect the pattern based on the inner characteristic of the input data. Okay, you use algorithms to detect pattern. I say detect pattern. Okay, for example, this is red color, is one of pattern. Okay, then have some tips here. Is one of pattern, and this is orange color, and this in this shape. Okay, this is the inner characteristic of the pattern. Okay, after that, you will use this pattern and then lastly to group them together. Okay, so one of the example of this unsupervised learning is called clustering. Okay, clustering. From here you can see that after you have detect this could be the same data, after go through the model training, unsupervised learning model training, they will group them together for you. Okay, they will group them together for you. Again, even though they have grouped them together for you, you are the one that to put the label Y. I mean, to put a label for that. This unsupervised learning. Because unsupervised learning, again, there's no output. You are the one that after you use algorithm, they help you to group this data together based on the inner characteristic, and then you are the one that give the label to them. Okay, so you as a human, you know that this group maybe is this label A, label B, label C, something like that. You are the one that give a label to them. So that's why from here, after they group them together, okay, you are the one that this is apple, you put a label. It's a banana, put a label. This is a mango, you put a label. You are the one as a human to put a label to them. Okay, that is unsupervised learning. Okay, so and give you another example. Okay, so from here you can see that this is another example of unsupervised learning process. So this algorithm processes an unlabeled training data set based on the characteristics over here. Then it group them into two different clusters of data. Okay, so from here, can anyone tell me? Okay, just asking a question. And you tell me, how do they group them together? Based on this picture here, how do they group them together? Okay, assume that you don't know this cat and dog. Okay, assume you don't know, but how do they group them together? Any things that this group have is common, anything that this group have is common. Okay, what is the inner characteristic of this group so that the unsupervised learning model know that this will be in the same group? Okay, for this one as well. Okay, how do they know that they're in the same group? Anyone know? What is the similarity for this group? What is the similarity for this group? Color, not really, because you can see this is also black color. This is also black color. Yes, face is one of them because you can see that the nose is longer. Cat, the nose mostly is shorter. Okay, that's could be this one of the characteristics as well. How about others? Ears, yes, ear is one of them. Okay, other than that, it's the claw. Okay, the claw. Okay, I think so. It's a claw. Okay, cat tend to have a shorter claw, something like that. Then dog that tend to have longer claw, if not mistaken. Okay, so this is just some example how they differentiate of each other. Other than that, of course, if it's not based on picture, okay, it could be the voice as already. Okay, some cat voice and dog voice, they're different. Okay, based on this inner characteristic, the unsupervised learning will know how to differentiate them. And then after that, you're the one that, okay, this is I label as dog. This is labeled as cat. Okay, that's unsupervised learning. Okay. So the definitions, what's definitions of unsupervised learning? Okay, it's unsupervised learning is a type of machine learning where the model learn to find a pattern and structure in the unlabeled data. Again, we have labeled data set and unlabeled data set. Just a recap, labeled data set is the one that already have the output, which means that based on this input, it already have the output. For unlabeled data set, you only have input, it don't have output. Okay, so sometimes most of the case in the real world, we have unlabeled data set. Okay, so you need some assistant to help you to find the insight from that unlabeled data set to give you, now I know that this data, they can group like this. Okay, then you, the one that give them a label. Later I'll give you some examples. Okay, so this model can actually discover the hidden relationship in the data by identifying similarities, difference, and cluster of the data point. Okay, sometimes it's fun to know that, okay, you know that you will find an unexpected result by using the unsupervised learning. Okay, so for this unsupervised learning, okay, it have two types of unsupervised learning. First is called clustering, and then one is called association. Okay, so let's go through one by one. Okay, so the example of clustering, right? Okay, suppose, just give you an example. Suppose a telecom company, telco, okay, want to reduce its customer churn rate. Okay, what is meant by churn rate is something called attrition rate. It's the rate at which customers stop subscribe. Okay, that's called churn rate. You want to reduce this churn rate. So which means that this telco company want the customer to keep on subscribe to the postpaid or prepaid, something like that. So they want to reduce this churn rate. Okay, so by providing the personalized call and data plan. Okay, so how they do that? Okay, so from here, they observe that some customer call duration is actually quite high. Other may have high, have heavy internet usage. Okay, so which means that some customers tend to call a lot, but use very less internet. Okay, some customers tend to call very less, but use a lot of internet usage. Have a higher internet usage. Some of them, they are between them. Okay, so from here, you can actually use the algorithm to actually help you to group them together. It's called clustering. Okay, based on all data here, they can group this customer whether they are belongs to E, belongs to B, or belongs to C. Okay, for example, if it's A, means that they tend to call a lot. They also tend to use a lot of internet usage. Okay, so from here, they may provide some plan that have a higher quota and also free call, something like that. Then the customer will start to subscribe. This group A of customer will tend to subscribe to it because I have higher internet usage. I have a higher quota. I also have free call. It's good. Why? It's good. I want to subscribe. Okay, for B, for B is moderate. Okay, so it's moderate. So call also quite less. Okay, so for this case is they can have another plan. Okay, for example, moderate quota and also maybe some free call. So this customer in group B will subscribe to it. Okay, and then for C, for C is they have very less of internet usage and also higher call directions. Okay. So from here, you can give another subscribe so that it can benefit to this group C. So based on this, the telco will actually come up the plan that want to reduce the customer churn rate. Okay, this is one of the clustering example. Okay, so for associations, okay, for association, this is one of the unsupervised learning as well. So this is based on customer purchase behavior. Okay, you might wonder how the retail shop make a lot of money. Okay, how do they do that? There's the secrets for that. And let me tell you what's the secrets, how the retail shop or maybe those big supermarket, how they make money. Okay, they actually based on this association supervised learning example. Okay, for example, customer A tend to buy bread, milk, fruit, and wheat. In one receipt, they found out this data. For customer 2, they will buy bread, milk, rice, and butter. You have another data here. So from this data, if there's a lot of this data, okay, the association algorithm can actually tell you that if a new customer purchases the bread, okay, it's likely that he will purchase milk too. Okay, he would likely to purchase the milk. Why? Because you can see in the previous data, you know that there's bread and milk together. Bread and milk together, milk together. So you know that the new customer, when you buy, you most likely will buy a milk. But how do you know? Okay, again, you need to use some algorithm to help you to find this is a hidden relationship for all the customer, all different kind of customer. Are they going? This is where all the product, whether they are associated to each other or not. If the retail shop know that based on the data I have, okay, the unsupervised learning give you some data, give me some insight already. Now I know that most of the customer will buy bread and milk together. Then I can come up with some strategy. Okay, I can actually come up with some strategy and some recommendation. For example, the retail shop can place the milk, can place the bread and milk together. I mean, not together. I mean, just place it next to each other. Place at the rack that next to each other. So that the customer, when they buy a bread, you just need to walk a few steps, take a milk. Then this will increase the profit of the retail shop. Okay, other than that, some of the retail shop, you know that customer will buy milk and bread together. Sometimes they will give a discount for milk. Okay, maybe milk, right, can if you buy a part of them, I mean a package, a set of them, you will have discount. Okay, so they know that when the customer buy a bread, they also will buy a milk. So if the milk have discount, the customer definitely go and take it. Okay, still some trade secrets behind. Okay, how the retail sale increase the profit. If you go to like those supermarkets, bigger supermarket, you will know that. Okay, I just want to buy one thing. Okay, I want to buy milk. I want to buy bread only, roti. Okay, I want to buy bread roti only. But at the end, your cart is full already. Okay, I just want to buy one thing, but why suddenly I buy other things? Okay, that's why how they present their product, how they arrange each other. So based on the data they have, they know that this customer, when they buy this, they will definitely buy another one. So they somehow make some magic, okay, to reach a shop nicely so that what they want you to buy a lot of things. That's their goal. So that's why they have this kind of unsupervised learning to help them find some relationship between what the customer will buy. Okay, so yeah, that's what is happening behind. Okay, so the applications of unsupervised learning, just now I already told you, market basket analysis. Okay, so is actually based on the algorithm that if you buy a certain group of item, you are more likely to buy another group of item. Okay, they have this analysis. Okay, it's one of them. And then semantic clustering, perform semantically similar words, share similar context that people post their query and website in their own way. So semantic clustering also group all the responses in a cluster where some meanings to same meanings to ensure that the customer find the information they want quickly, okay, and easily. Okay, then we have the delivery store optimization. So this model are used to predict the demand and keep up the supply, also to open store where demand is more and optimize the routes for more efficient deliveries based on the data. And lastly, the identify accident prompt area. Okay, you can use this to know that that is the high accident area, so they can put some sign to tell that to tell the driver that that is the high accident area, so to be more careful. Okay, so I already talked about all the concept already. Okay, let's do some demo. I will do some demo. Okay, so but before that, I just let you know that this is some example of the what is the algorithm or model in classification and what's the model in regression. So from here you can see that for classification, these are the top rank, I can say top rank algorithm in classification. For example, logistic regression. Okay, from here, don't confuse yourself. If you see regression, doesn't mean that it belongs to regression. Okay, it's just, I mean, yeah, it's a name. Okay, it's a name. Logistic regression is belongs to classification as well. Okay, then we have a decision tree, random forest, SVM, and base and KNN. If you work on some project by using AI before, maybe you already use one of them. That's classification. For regression, we have a linear regression, Lattice, SVR, and also random forest regression. These all of them, they are used to predict a number. Okay, for example, that in that pictures got how many people inside is to predict a number. Okay, so let me just do demo by using regression. Okay, demo by using regression. Okay, I use a easy to understand one so that you all can quickly pick up, quickly know what's behind the scene. Okay, the linear regression. I will use linear regression as example. Okay, so this is example. This is use case implementation of the linear regressions. So we want to estimate the profit of a company. Okay, so a company is trying to understand how much should they invest in the advertisement. Okay, in the advertisement, okay, how much should they invest? So in the advertisement, here is in the form of TV, okay, radio, newspaper. This, when the company want to advertise their product, right, they can invest, okay, into making the advertisement in TV, okay, make an advertisement in radio, and make an advertisement in newspaper. From these three, they want to know that how much they want to invest so that it will actually what's the profit they can make. Okay, how much they want to invest so that advertisement can expose the company to everyone. Okay, so if a lot of people know this company, they will go and buy their product, something like that. So how much they want to invest into in the form of TV, radio, or newspaper, and then from here, how much they can take in return. Okay, so for this case, it already have the past data. The company already have past data. Okay, in the past data, how much they have invested in TV, radio, and newspaper, and how much is the profit. Okay, in the past year, in the past few years, they already have this kind of data. So from this data, so next year, based on all this data, you can come out a linear regression model to predict, okay, do predictions, how much they can earn. Yes, you can do that. Okay, I just give you a general form. Okay, of course, in the real world, it's more complex, but I give you a general form. Okay, general idea, how does it look like? Okay, so let me just change my screen to the examples here. This one. Okay, so this is example of use case implementation of linear regression. So I just now already told you that we want to use the past data, how much they have invested in the advertisement, and make the predictions. Okay, so from here, you can see that this is the Pythons. Okay, for machine learning, deep learning, right? Most of them, they are using Python programming. Most of them, I can say 99% of them, they're using Python programming. Okay, I believe that if you already done some AI project, okay, I believe also using, I mean, if you are doing machine learning kind of project, right, I believe that you also use AI. I mean, sorry, you also use Python programming. Okay, so this one just to let you know that what's happened behind the scene. Okay, so we have a few steps here. 1, 2, 3, 4, 5, 6, 7, 8. Total of 8 steps. Okay, I will show you one by one. Okay, so what is happening behind the scene? How do you start with data set? How do you train it? And how do you evaluate it? Something like that. Okay, so for this case, it will start with importing the library. Okay, importing the library. So these are the library. Okay, we have pandas, seaborns, something like that. These are the libraries. So let me just run it. Okay, so the library is already imported. So these are all libraries that use to implement these linear regressions. And then we have a data here. Okay, this data is from the CSV file. Okay, maybe I can show you the CSV file. Okay, this is data. Okay, this data. So from here you can see that TV, how much they have invest. Okay, in the radio form, how much they have invest. This is in $1,000. Okay, the unit is $1,000. So this $330,000 they have invest, and then what is the sales they have? What is the return of? What is the profit they actually make? Okay, so we have a lot of them. These are based on past data. These are data in numbers. Okay, so this is data. Okay, and then from here we want to import, load data set. Okay, and extract the variables. So we load the data set and we need to confirm that the data set is already inside the system. So we can print out the first 5 data set. You can see that this 5 of them is from the just now the Excel file, the first 5 of them. Okay, this is to import the data set to be trained, and then we can somehow visualize it. Okay, you need to have some experience to visualize the data. Okay, from here you can see that when I visualize it, you can see that this based on how much they invest in the TV. For example, this column is TV, the middle one is radio, right side is newspaper. Okay, based on how much they have invest, the dot here is the profit. Okay, the dot over here is the profit. Okay, from here you can see that TV is somehow related, have some effect in sales. Okay, why I say that? Because you can see when it increase the amount invest in TV, you can see that the sales is actually increased. And you can see the pattern here. Okay, you can see the pattern is actually increased. How about radio? Radio somehow it got increased, just somehow, but it's quite scattered. The dot here is quite scattered. Newspaper most likely not really help in this model when it's used for training. Most likely it's not helping. Okay, you can see that when the amount is increased in invested in newspaper, right? You can see that it didn't actually follow the trend. Okay, so after you have trained the model, okay, you got the result already. If you, let's just like I say that you want to tune the model, right? Okay, maybe you can think that newspaper, I don't want to use it anymore. Okay, newspaper, I want to remove the data from newspaper and try to train again. Yeah, if you somehow find higher accuracy by removing the newspaper, then you can tell the company that just invest in TV and radio. That's it. Okay, newspaper no need because it didn't show you any profit. This is high level kind of analysis already. But for now, we stick to this. Okay, for now we stick to this. Okay, we have TV, radio, and newspaper. Okay, and then we start to prepare our X, which is the input. We have a Y as output as well. Okay, for this case, this is a code to prepare the input, which is an X, content of TV, radio, and newspaper. There's an X. So now I say that supervised learning, we have X, right? This is the X. Okay, you can also print out how many data you have. So we have total of 200 data. Okay, and each data have 3 columns. So 1, 2, 3 columns. Okay, and then you can print out the Y as well. Y is the label from this data. Okay, so this is what I call label data set, because each line of them, this is the output. Based on this input, when I highlighted, this is the output. Okay, so this is what I call label data set. Just now I already mentioned what is label data set. Because you have X, you have Y together. This is called label data set. Linear regression is a supervised learning. Okay, and then this one just to check how many of them, we have 200 of them, which is correct. Okay, now let's start those. We have all the data, we have total of 200 data. So we want to actually split them into training data set and testing data set. We want to separate it down out. We want to reserve some data used for training, okay, training a model, and some data used to test your model. Okay, so at the rule of thumbs, in general, Let me just import this one first. Okay, in general, we are splitting 75% for training and 25% for testing. Okay, so after you're doing that, you can see that training, you will use 150 data for training. You use 50 data for testing. Okay, 75%, 25%. And then after you have X, which is the training data set, and also the testing data set, we can start to train the model. Okay, so this is just a simple code to train the model. Okay, so after we have trained the model, you can see that we have 200 data only. Okay, which is not really many lah. It's not it's not a lot. So this is the line that a simple line to train the model, is to train the model. So once I run it, you can see it's very fast only because 200 data is not that many. Okay, so the model has been trained. Then you want to test whether it make the correct prediction or not. Okay, so from here you can run it. Okay, based on the testing data set, these are the prediction it made. And you can see there are a lot of numbers, right? Then how do you know the performance? Whether all these numbers, they are correctly predicted or not. Okay, each of them is actually based on the input. Okay, the TV, radio, and newspaper. These are the profit they can make. But there are a lot of numbers here. How do you know the model have very high accuracy, whether its prediction is very good or not? How do you know? That's why you need to have a last step, which is evaluate the model. Again, to evaluate the model, you need to know that which model you are using and choose the correct evaluation matrix. Yeah, choose the correct evaluation matrix. So for this case, it's a regression model. Most of the time, it will use mean absolute error, mean square error, and root mean square error. These are the standard, okay, standard evaluation model for regression problem. Okay, so you just run every one of them. Okay, so since this is error, you want to have lowest number as small as possible because it's error. Okay, so from here I can see that error is 1 or something, near 2 and 1 point something. So you can based on, you also to do the verdict that whether this model is good or not, you must base on your own experience as well to see that whether this is good or not. Okay, so from this case, the error is quite low. Okay, from my experience, I say that, okay, this model is good. Okay, some of you may not agree because based on your experience, you say that this is too high already. It's not that good. Okay, then if it's not good, then what's the next step? Just like I say that the next step you can do is, again, based on experience, you found that maybe newspaper is not useful because you can see from the visualization here, the more you invest, it didn't actually give you a lot of profit. Maybe the next time you train the model again, you want to remove the newspaper, and then maybe the error will be lower. Okay, that's just a simple demo. Any questions? Any questions from this demo? This using Python. Okay, using Python to do the linear regression demo. I do a demo for you. Any questions? Okay, no question for now. Later I have another Q&A questions. Okay, so after I've done everything, so if you have any question, you can ask. Okay, so if no questions, that's the end of the machine learning part. Okay, why I talk about a lot about machine learning, because that's the base and that's the fundamental knowledge. Okay, a lot of things that you learn from machine learning, okay, when you go for deep learning, some of the concept, they are still the same. Okay, so that when you go for deep learning, some of the things that you will not, some of them that you learn from deep learning, you may not feel unfamiliar. Okay, so because there are some terms that I already mentioned in the machine learning. The more trained data set will have higher accuracy. Yes. If your data set have a lot, just now the data set only have 200 data. Of course, if you have 1,000 of them, 2,000 of them, the accuracy is higher. Of course, the accuracy is higher. Again, there are some something behind also to actually tune your model. Okay, to actually tune your model so to have a best accuracy. But in general, the more data set you have, I mean, the more data you have in the data set, it will increase your accuracy because your model actually trained with a lot of data. That it will increase the accuracy. Just for example, you ourselves human, okay, if you work at the same area for 10 years, compare the one that work in the same area in 1 year, which one have better accuracy? Okay, of course, those who work in 10 years have better experience, have better accuracy, something like that. And those who work, it's just like new 1 year only, they don't have good experience, maybe they don't have very good accuracy, something like that. Just for example. Okay. We'll have overtuned or model overtrained. Yes. That's why I say there are some steps that you want to avoid this overtune, and then what is called overfitting. Okay, another term is called overfitting. Okay, you want to avoid the model to be overfitting to the training data set, which means that more bias to train data set already. There are some things that can help you to avoid this. There are some algorithms. Okay, for example, you can use the just give you some terms. Okay, you can use the cross validations technique. Okay, maybe I just write it there. Cross validations technique. Okay, cross validation techniques can help you to avoid the overfitting issue. Okay, so there's one question: how do you know which model to choose? How do you know which model to choose? That's a quick question. Okay, first of all, how do you know? It depends on the problem. First of all, if your problem is to predict a number, then go for regression. Okay, go for the model inside regression. Let me just show you. Okay, so how do you know which model? If let's say you want to predict a number, then go for techniques inside the regression. Okay, if you want to predict a class, let's just start and say want to predict that is a dog, cat, bird, something like that. That is a class. It's not a number. Then go for classification. Pick the model from classification. And then, for example, now you know that my problem is lie within regression. Then which model to choose? Okay, so if you have time, pick all the model and find out which one is the best. If you don't have any idea yet, okay, if you're the beginner, you know that my problem lies within regression, and then you don't know which model is the best. So my advice is use all the model first. Okay, put all the data into all this model and see which one is the best. So the next time you encounter the same problem, you know that, oh, it's regression. This is good. Pick this one. Then you have experience to choose which model you want to use already. It's all based on experience. Okay, that answer your questions? All right. Okay, let's move to deep learning. Okay, deep learning, machine learning model is done. Now it's deep learning. Okay, so why you have deep learning? Okay, machine learning model already have it, right? Okay, why you want to have deep learning? Just for your information, deep learning only come into picture like 10 years or 15 years ago, maybe 10 years ago, 10 to 12 years ago. Before that, there's no deep learning. Okay, why suddenly they have this deep learning? Okay, so the reason is there's a limitation in machine learning already. Okay, there's some limitation in machine learning. Okay, I think it's 2012. Okay, so there's some competitions. There's a competitions to recognize based on a lot of pictures. Okay, they have a competitions for you to write an algorithm to recognize as much picture as possible. Which, for example, in that picture, what is the object in that picture? Okay, there's a competition called ImageNet, I think. Okay, there's a competition for that. So that's why from there, someone come up deep learning, and then it defeat all the participants they're using machine learning. That's why from that moment, deep learning boom already. Okay, so that also unreal that there's limitation in machine learning. Okay, so what is limitation in machine learning? So first of all, it's not useful while working with high dimension data. Okay, high dimension data, that is we have a large number of input and output. Okay, previously 10 years, 20 years ago, maybe 10 to 15 years ago, not many things they are digitized. They are still in analog, which is in paper. Okay, a lot of things they are still in paper. But now you can see everything is there online. Everything is data. Everything is digital data. So we have a lot of data now. Okay, so that's why machine learning may not be useful anymore. Okay, when you have a lot of data, when you have high dimension of data. Okay, second is it cannot solve those crucial AI problems like NLP. And sorry, NLP stands for natural language processing, which is recognize your word, recognize text, recognize the text. Okay, so machine learning may not be useful anymore, and image processing as well. Okay, there still are two things. So what other thing is another bigger challenge in a traditional machine learning model is the feature extraction. Okay, feature extraction. Machine learning may have some limitation to extract the useful feature already. For example, for those complex problems such as object recognition, handwriting recognition, these are the huge challenge if you want to use machine learning. For example, you can see the pictures here. In this picture, previously for machine learning, one picture only have one object, right? Just now you can see the image for that cat, right? In that picture only have one object, which is a cat. That's it. But now it's very complex already. You can see one picture will have a lot of objects. Okay, this is where the limitations of machine learning come in. Okay, it may not, most of the time, it may not recognize all of them already. From here, you can see that if you're using deep learning, this is an example of deep learning. Okay, if you're using deep learning, it can recognize this is chair, this is a bag, cup, laptop, so on and so forth. It can recognize everything. Also, handwriting, machine learning may not done well already. Well, this is a machine learning guy, okay? Cannot done well already. So they want to shift it to deep learning. Okay, so later I'll ask you a question now. Okay, after I finish deep learning, maybe I'll ask you one question later. Okay, but let me just move on first. Okay, so that's why they come out this deep learning. Okay, these deep learning models are capable to focus on the right features by themselves, figure out the right feature by themselves, require a little guidance from the programmer. Okay, so these models are partially solve the dimensional problem as well. Deep learning is implemented through neural network. Okay, neural network. So they actually come up this deep learning framework based on our human brain. Okay, so the motivation behind neural network is the biological neuron. If you study bio, some of them, if you're from science school, study bio now, do you all learn brain? I mean, the things that behind the brain. Anyway, okay, the brain is actually made out of neural network. It's called biological neuron. Okay, that's the idea behind deep learning. Okay, so that you can build a complex model to learn complex things. Okay, why they want to mimic our human brain? Because our human brain is very smart. We can learn a lot of things, right? You can see ourselves here. You can learn a lot of things. Okay, you can learn different kind of language, something like that. You can actually pick up that as a cat, that's not a cat, something like that. Okay, that's why there's something that you can harvest from our human brain. So that's why they have come up with this deep learning. Okay, so why we need a deep learning now? Okay, gives you an idea. Okay, so why they shift more towards deep learning. Okay, first of all, it works well with unstructured data. Okay, machine learning work only on the large set of structured data, while deep learning can work with both structured and unstructured data. Just now I say that structured data is the data from table. Just now I show you the advertisement, the table, right? Unstructured data is from, like, for example, image, audio. Okay, deep learning can learn that as well. Okay, so second is they can handle complex operation. Okay, they can perform complex operation easily, while machine learning algorithm cannot perform anymore. Okay, that's the deep learning. Then, so it can extract a lot of features. So machine learning algorithm use label sample data set to extract pattern, while deep learning accept almost everything. Okay, large volume of data as input and analyze the input to extract the features. So lastly, achieve better performance compared with machine learning. Okay, the performance of machine learning algorithm actually decrease if your data increase. Just like I say, if in 2001, 10,000 of them, machine learning may not perform very well already. Okay, so to maintain the performance of model, deep learning is needed. So deep learning can perform if you have 10,000 of data. Deep learning is much more better. again, there's a trade-off between, there's a trade-off for deep learning as well. Okay, so before I go into what is neural network kind of things, right? Okay, so my question is machine learning and deep learning. Okay, you already know that deep learning is more better performance than machine learning. Okay, my question is, do you think that machine learning is still there? Okay, when you have a problem in front of you, the problem you want to solve, whether you want to pick machine learning or pick deep learning, which one you want to go? Okay, so they have some things that can help you to pick whether you want to go for machine learning and deep learning. Okay, so the question is machine learning is still there or not? Is still using or not? Okay, because why? Because deep learning is more advanced, right? Why they want to stick with machine learning? Okay, the answer to this is both still exist. Both are still exist. Machine learning is still there. Deep learning is still there. Okay, why? Again, it depends on your problem. If your problem is not that complex, okay, maybe just to predict yes or no, something like that. And your data set is just like 200 of them, 100 of them, maybe 1,000 of them. Okay, so for this case, machine learning may give you better result. Okay, so if you have data is very complex, then you found that machine learning cannot cater anymore, then just go for deep learning. Again, there's some trade-off for deep learning. What is trade-off is the resources used for deep learning is very, I can say expensive or very high for the resources used in deep learning, because you need to use some good graphic card, good GPU. When you are doing training, okay, when you're dealing with 10,000 of data, okay, you need to have a very good hardware, processing hardware platform to train all this data. Okay, else it will train for 1 week. It also haven't finished. So you need to have a very good. So the workstations to train a deep learning data, right? To train a deep learning model, usually the workstation will have a very simple GPU. Will only have a very simple CPU, but a few high performance GPU graphic card. Okay, usually it's 2 of them. Okay, so this workstation is not for gaming, it's just for training the data. Okay, for those industrial grade one, it will be more, the graphic card will be more industrial grade, will be more expensive. Okay, so let's say that's a trade-off. Because machine learning, right, if you just use a normal laptop, it still can do it. Because it's not that complex. It's not a hunger for resources. But for deep learning, yes, it need to have a very good GPU to train your data. There's a trade-off between them. So which one you want to pick depends on the problem. Okay, so that's the machine learning, deep learning. Okay, so now let's go into the neural network. Most 11. Okay, so neural network, what is meant by neural network? Okay, that's behind the scene. What is these things that behind the scene of deep learning? Okay, neural network are modeled after our brain, biological neural network that allow computer to learn and interact like human do. Okay, so it's like Terminator or something like that. Okay, so we have an interconnected neurons with dendrites that receive input, and based on this input, it produces an electric signal, which means the output to an axon to other neuron as well. Okay, so from here you can see that this is if you study bio, this will be maybe quite familiar to you. This is our neuron. Okay, we have some lines here. These are all electric signal. Our body, they are controlled by using electric signal. Okay, so they have the hills like this. This is connected to another neuron. Okay, so they are using this to actually come up to something like this. Okay, let me explain what is this. Okay, so from here you can see that this is our neuron. Okay, so all these have some representative. So for example, this is input. Dendrites from neuron is actually your neural network input. This is the input from other neuron. Okay, you can see these are input from other neuron because these are connected to other neuron, right? So this input from other neuron. Okay, and then you have input electric signal from other neuron. Then you will go for processing. Okay, before that, there's a read. Okay, there's a read. This is a synapse here. Okay, synapse here. Okay, so The mathematics behind is it will use the input that received, multiply with the width. Okay, it's a width here. And then all this will pass to a neuron. Okay, where this neurons is the nucleus. What you call processing unit, processing element is a neuron. Okay, after you have gathered all the signals here, after you have processed, okay, so this neuron will go through what they call activation function to decide that whether the signal that you process, you want to pass to another neuron or not. That's what we call activation function. Okay, if you understand, don't understand now, doesn't matter, just picture. Okay, just picture what is happening behind the scene. Just a simple one. Okay, so again, the signal that has received, it will process. After it process, whether to pass to the output, which is another neuron or not, is based on this activation function. This activation function have a lot of different kind of activation function. Okay, for example, value, something like that. Okay, then where is the output? Output is here, is action over here before it pass to another neuron. So our brain, there are a lot of things happen. When I'm talking now, you're processing, right? Your brain is actually process it. Okay, there are a lot of signals coming here and there. Okay, then they will do some inside, they will do some processing, something like that. Then before it pass to another neuron, then neuron pass to your memory to save it. Okay, something like that. Okay, so this is what is happening. This is just a very simple form. Okay, just to tell you that how the deep learning neural network actually mimic our neuron. Okay, something like that. Okay, so let's see some working of how the neural network work. Okay, working of neural network. Okay, so for example, I have 3 pictures here, which is a square, circle, and a triangle. Okay, so from here we have input, this what I call input layer. We have a hidden layer, and then we have an output layer. So all of these, they are neuron. Okay, all of these, they are neuron. So all of them actually connected with each other, something like this. They are all connected to each other. Okay, it's same with our brain. All the neurons, they are connected to each other. Okay, there are, I think, million of them, should be million of them, okay, in our brain. They are all connected together. So each of them, they have some values. Okay, so for example, for this case, you can see that at the first input layer, we have 784 of them. Okay, why? Because assume that this picture is 28 times 28 pixel. Okay, the resolution for this picture is 28 times 28. So you have 784 pixels. You have a total of 784 pixels. Okay, so this 784 pixel, it will be each of these pixels will be go into this input layer. So you can see that this pixel number 1 until pixel number 784, they all go into one single layer. Okay, each of them will go into it. Okay, and then you can see that this is what we call just now the weight. Each of them have some weight. This weight, it can be randomly initialized. Again, that is part of the step in the deep learning. In the deep learning, this weight can be, they have a lot of method to initialize the weight before you do a training. Okay, so this is just a randomly initialized, all this weight. Okay, between the neuron, they have some weights here. Is the number. After that, so now it will fit this image into this neural network, and it will go from left to right. Okay, the signal will go from left to right. So when it go from left to right, okay, there are some, just now I say that there's an activation function inside to determine whether the signal, after it's processed by this particular neuron, whether to pass to the next neuron or not. So there's an activation function. So when you do processing, right, you can see that some of the signal may pass to the next neuron. Some of them, you can see these, they didn't pass to the next neuron. Okay, because maybe the weight here is too small already. No point that, which if the weight or if the value is too small, means that that feature is not meaningful. Okay, just for example, that feature is not meaningful. So that's why no point that it passed to another neuron. Okay, just stay on this neuron, that's it, end of story. For example, this one. Okay, it just stay on this neuron, it didn't pass to another neuron. So to determine whether to pass to another neuron is actually depends on the activation function. Okay, activation function. So for example, you can see that only this 1, 2, 3, 4, this layer, only 4 of them they activated. Just for example, okay, 4 of them activated. They receive a signal from the previous layer. Okay, after that, they will also do some calculations here, and then only the next layer, only 2 of them they activated. Okay, the signals here only pass 2 of them to the second layer, third layer. Okay, and then you do the prediction. Based on the signals here, based on the value here, you do the prediction. For this case, for the first time you do the prediction, this is what we call forward propagation. Okay, when the signal pass from left to right, it's called forward propagation. So from this case, you can see it predict is square. Okay, but it's a wrong prediction. It's a wrong prediction. Then, just like I mentioned, right, the neuron will adapt to itself. It will adjust to itself automatically. If it make a wrong prediction, it will adjust itself. All these numbers here, you can see all these numbers here, they will adjust itself by using some optimization techniques. Okay, it's the same with ourselves as a human. If we make a mistake, we will adjust it. Okay, adjust it, and then next time you won't make the same mistake. Or for example, you actually bring basketball, you want to throw the ball into the basket, right? So for the first time, you stand in the same position. The first time you throw, it didn't go in. Okay, so what you will do at the second time, you will adjust, right? You adjust the angle, adjust the force, the strength from your hand, so that the next time you can throw it correctly, adjust it yourself, and throw it to the basket. It's something like that. It's the same thing. Okay, so this neural network will do the adjustment. Now, first time you know that, oh, the neural network know that it predict wrong. Okay, what it will do? It will do what I call back propagation. Okay, using some techniques here, there's some techniques here. It will do back propagation, go back again. Okay, there's some error functions here, loss functions here. There's some techniques here. It will do back propagation and adjust all these numbers, all this weight. Okay, it have some algorithms. Okay, so it'll adjust all. There's some formulas to adjust all these weight, all this weight. Okay, until you can see that this weight they are different already. Okay, this week they're all different already. Okay, so you do forward, backward until the weight are all optimized already. And the next time you do the prediction, you will do the correct prediction. Okay, so how does it happen? Okay, how does it happen? So again, they will involve some programming. Okay, they involve some step for you to set the correct optimization function so that it will adjust the weight correctly. Again, there are a lot of them. There are a lot for you to learn. If you want to go deep into deep learning, there are a lot of things to learn. Which one is better? Which one is the optimized formula to adjust it? How fast it can adjust, so on and so forth, until it can predict the correct prediction. Okay, so this is deep learning. Okay, this deep learning. So they always have forward propagation. If you predict wrongly, then you use some techniques to when you go back again, you adjust all these grid and then do the prediction again. Okay, if it's still wrong, then adjust again. Adjust until it can correctly predict the correct one. And then you achieve higher accuracy already, then you can determine that that's the best model already. Okay, so this is what is happening behind neural network. Okay, again, I didn't go very in depth, okay, but just give you a rough idea, okay, what's happening behind the neural network. Okay, any questions for deep learning? No, okay. Now it's about 11. Okay, I think I will have plenty of time for Q&A because I didn't have too much slide left. Okay, anyway, okay, deep learning. Okay, no questions. Okay, let's move on. Okay, we have start. If still have time, maybe I do another demo by using machine learning. Okay, just now I do a demo for regression, right? Maybe I give you another demo for classification. Okay, let's finish a slide first. Okay, so you already have a concept of deep learning. Okay, now let's go into generative AI already. Okay, why now I only go into generative AI because generative AI, what is happening behind, they're actually using machine learning and deep learning together. Okay, in the real world example, right, usually deep learning and machine learning, they are used together. Sometimes the pipeline for this is they will start with machine learning, then go into deep learning, and then only get the result. Sometimes they start with deep learning, then go to machine learning, then only get the result. Okay, so these happen all the time, okay, because they both of them have their own strength. Why not you just combine them together and harvest this strength and give you a better result? Okay, in the real world, it most likely it happen like this. Okay, so that's why I want to give a basic fundamental idea first before I go to generative AI. Okay, so what is generative AI? Okay, generative AI is a form of AI. Okay, processes the ability to generate a wide range of content, including text. Okay, then give you a text, and give you a visual, give you audio, and synthetic data. Okay, if you use some generative AI before, the one I used before in most of the time I think is ChatGPT. That is the one that give you text. Okay, some of them, the generative AI, you use it right. It just give you. You just need to input. I want a picture with some mountains behind, with some village in front, with a river. Just a simple text only. Then it will generate the visual for you, generate the image for you. That is one of generative AI as well. Okay, so now I think if you watch a video from online, right, you will see it's quite impressive already. You can actually generate a lot of things. Okay, sometimes the characters from maybe from anime or manga, right? Okay, those are very old image. You can use generative AI to help you to generate the modern image. You can do that as well. Some of the pictures they only have black and white. Generative AI is able to help you to convert those old picture with black and white only. Based on this, it will give you the color picture. You can do that. Okay, so generative AI is used for creating, ideas and content, also in the term of generating fresh original outputs, using a variety of media like video, books behind. Okay, so but today we just focus on LLM. Okay, I have a few slides about LLM, and in the afternoon you will know how to use ChatGPT, some what is about prompt engineering, and also how to use API. That's the afternoon section. But for now, just give you an idea. LLM is mostly based on text to generate text for you. Okay, so before I go to LLM, okay, what is the advantage of generative AI? Okay, so I think if you use before, you already know some advantage. First of all, it automating the labor-intensive process of content creation. Okay, it actually reduce the labor. Okay, second is lowering the effort in writing emails. Yes, yeah, I love this one. Okay, if you help me lower my effort in writing the email. Okay, so third is increasing the responsiveness to technical queries and making a logical story out of difficult facts, and also can streamline the productions. So these are just some of the advantages of generative AI. Okay, again, if it's someone asks AI will actually replace my job or not, okay, I don't think you need to worry, okay, because AI is we as a human, AI is most of the time is to assist us, okay, assist us, okay, so that you can actually streamline your job, increase your productivity, so on and so forth. Okay, so large language model. Okay, large language model. So what are large language model? Okay, so large language models are machine learning models that use deep learning algorithm to understand natural language. Okay, why you want to have very good in understand your natural language? Because, for example, the GPT, okay, the GPT. So the word is chat GPT. Okay, chat. Okay, how do you input to the model is by typing English or typing. I think I think now it actually receive not only English, they actually can receive different kind of language already. So that's the first step to understand your language. Okay, if the model is not good in understanding your language, then that's if the input is not correct, then the output is not correct. That's why, okay, I am actually very good in understand your natural language. Okay, so this model use self-attention mechanism to analyze the relationship between different words in a text and enable them to capture contextual information and generate contextual responsive. What is meant by different words? So if you type in the words, right, for example, write me an email, write me an formal email to apply leave, to apply budget, something like that. Okay, so these are the words in the sentence. So this sentence have few words inside. So the model need to pick up the correct words and generate output for you. It must be very good in pick up the words and change it into what you call token so that it can generate output for you. Okay, so this model, they can understand complex textual data. Okay, textual data. Okay, also can understand you can actually do some semantic analysis. Okay, do some semantic analysis, and then chatbot conversation. They are using chatbot conversation, and lastly, some translation. Okay, so translation you can use GPT to help you. Okay, to then other than that, understand different kind of language, do sentimental analysis. Sentimental analysis is like good, not good, angry, something like that. Okay, and then chatbot conversation. So yeah, some of students actually use GPT to do the chatbot already. Okay, so these are the applications. Okay, in by using LLMs. So how they train? Okay, how they train? This is what happened behind the scene. I'll just let you know. Okay, large training model typically undergo pre-training on a board, and comprising dataset that share statistical similarity with the dataset specific to a target task. Okay, so the objective of pre-training is to enable the model to acquire high-level features that can later be applied during the fine-tuning phase of a specific task. Okay, so what are the steps? Okay, I will give you an idea how they are trained. Okay, just a general idea how they are trained. So there are a total of 6 steps. Okay, first step is called text pre-processing. Okay, text pre-processing. So the textual data is transformed into numerical representation, which is number, okay, that can be effectively processed by the model. That's the first step. Okay, take your task and transform. The keyword is transform. Okay, later I'll tell you what is transform into a number. Second step, random parameter initializations. So the model parameters are initialized randomly before the training process begins. This random parameter initialization. And third step is the inputting numerical data. So the numerical representation of text data is fed into the model for processing. So the model architecture is typically based on transformers. Okay, transformers allow it to capture the contextual relationship between word. Word by word have their own relations. Okay, so they are using what we call transformer. Okay, to actually capture this relationship. Okay, so fourth is the loss function calculation. So a loss function is employed to measure the discrepancy between the model's prediction and the actual predictions. So this you can see loss function, just like I mentioned. Okay, you also use a loss function to actually measure the actual result and the prediction, whether they are correct or not. Okay, so they are still using loss function calculations. Okay, and then next will be the parameter optimization. So the model parameters, right, are adjusted through optimization techniques such as gradient descent. Gradient descent is one of the terms used in deep learning. Okay, but now you just need to know that this technique is used to reduce the loss. Okay, reduce the loss. So this includes calculating the radians and update the weights accordingly. So as I mentioned that during neural network, right, there's some weights. Okay, there's some weights numbers there. So this small number is called weight. WEIGHT is called weight. So how do you tune this weight? Is by using gradient descent. It's by using optimization function called gradient descent. It's by changing this weight. Okay, lastly, after you have set all this, is to train day by day, okay, iterative training. So this training process is repeated over multiple iterations or epochs. Okay, sometimes you heard about the word epochs. Epochs means that multiple training. Okay, until the model's output achieves satisfaction level of accuracy on a given task. Okay, so by following this training process, right, the large language model learn to capture linguistic pattern, understand context, and also generate coherent responses, enable them to excel at a wide range of language-related tasks. Okay, language-related tasks. So if we are using large language model to give you some result, right? Okay, so for example, you ask them to, I would say, give you some, if you have this programming problem, okay, so you maybe ask one of generative LLM, maybe ChatGPT, it will give you a result. Yes, it will give you a result. Okay, but you are the one that need to have a ability to know whether the result is correct or not. Because like I say, large language model, they are very good in language related tasks, language related tasks. Okay, it based on your input, it will go and find the result for you, matching result for you. But you are the one that need to have an ability to verify whether the result is correct or not. Okay, so this is the simple 6-step how the LM is trained. Of course, there are a lot of details inside. Okay, but now just to give you some ideas how they actually do. Okay, so how do the LM works? Okay, and behind the scene. Okay, well, the moment you insert a inputs, what's happening behind? Okay, so to give you an idea. Okay, so the LM models leverage deep neural network if they are using deep learning. Okay, to generate output based on the pattern learned from the training data. So for ChatGPT, I think the data is now until 2011, if not mistaken, the data is there. Okay, so this large language model sometimes have another word is called transformer model. Transformer model. Okay, the D here, the D is transformer model. Okay, so from here you can see that this general idea how a large language model works. Okay, it always start with inputs, prompts input. So later in the afternoon, you learn prompt engineering. How do you properly ask large language model giving? How do you properly ask the question? Okay, so I think Alex will teach you the prompt engineering. Okay, how do you properly ask the question? Okay, so there's a first step, prompt. Okay, which is to receive text input or sequence of word or large words from the user. Okay, second is tokenization of input, which is it will transform this input into individual token. Individual token, which means individual word. Okay, and it will take these tokens, go to that step is to encode this token into context vector or some mathematic representation. Okay, there are a lot of things happen at the third step. Okay, to match, find out which one is the correct data and give it to you. And after that, it will, based on all these things, it will give you the result, whether it's in article, lyrics, images, quote, song, and poem, something like that. That's just a very general idea how the LM works. Okay, so some examples of LM, just pick two only. Okay, there are a lot of them now. Okay, but I'll just pick those commonly used one. So this one, I believe that you're commonly used. It's called GPT-3. I think now they have GPT-4 already, GPT-4o. Okay, so have you ever know that what is GPT? And again, this is my question. Do you know that GPT stand for what? You know, ChatGPT always say, do you use ChatGPT or not? Okay, so what is GPT? Anyone know what is GPT? What is the full form of GPT? I know you can Google it actually. What's the full form of GPT? No answer. Okay, it's okay. Okay, GPT actually stand for generative. That's how I mentioned generative AI, right? Generative. G is generative. P is pre-trained. Pre-trained. Okay, there's a pre-trained model inside. the model is already there. It's already pre-trained for you. So you just need to use it. And then the T stands for transformer. Okay, generative pre-trained transformer. So you can see that just now I'm using some words, transformer model, right? Transformer. So just now I mentioned a little bit of transformer already because GPT, the T stands for transformer. So the full form of GPT is generative pre-trained transformer. Okay, it's from OpenAI. Okay, I think this one introduced in October of 2022, if I'm not mistaken. Okay, so by that, they actually open a lot of opportunity lah. Okay, so now AI will be actually more popular after that, even more popular. Okay, so GPT-3, okay, GPT lah, okay, is versatile for various applications. I can use a lot in different kind of application. They also actually excel in text generation, including articles and story. You want the GPT to tell you a good story, that's it, because it's a language model. It's a language model, and then it also enable accurate language translation across multiple languages, and also it provide details responding in question answering system. It's very detailed responding to this. Okay, so there's some features of ChatGPT. Okay, so there are a lot of things that you can work with GPT as well. For example, you can use cause an API, so you can link it with your applications. So when the user key in something, the GPT is the one that generates up and also pass it back to the user. It's all automated. You can do that as well. This is just an example. Okay, so other than that, I pick another one. It's called BERT. BERT is called bidirectional encoder representations from transformer. It's from Google. Okay, this is not new. I think it's from 2018. It's already there. Okay, so this the BERT bidirectional training captures context effectively for NLP tasks, natural language processing tasks. So other than that, it's popular for sentiment analysis. Okay, for example, understanding the customer feedback is sentiment analysis, whether it's good, bad, or not good, good, bad, or average. There's a customer feedback. Okay, so the BERT also excel in name entity recognitions, accurately identify entity like names and locations. So it also enhance some. It also have the enhanced machine translation system for accurate and fluent translation between languages. Okay, so this is called BERT. BERT. Okay, so actually reached the end of my slide already. Okay, so in the nutshell, what I have done in these 2 hours, okay, what I have I already mentioned, go through on these 2 hours. Okay, first of all is I already give you some ideas. What is AI, machine learning, and deep learning? What are them? Are they the same or not? Then some point whether they are same or not. So this one I will go through earlier in this morning. Okay, so next is the machine learning type. I'll give you some ideas. What is supervised learning? What is unsupervised learning? I'll give you some demo also for the regression just now. This is a demo. Okay, so by using some codes, how do you actually implement the linear regression? How do you see the result as well? Okay, and also the deep learning. Okay, what is deep learning? How does it look like, and how it actually designed according to our humans neuron? And then I'll go through some introduction of generative AI and also the large language model. So these are things that I go through this in these 2 hours. Okay, so before now it's 11:10. Let me do another demo. Okay, we still have time. Okay, so just now I already do a demo for regressions. Let me just do a demo for the classification. Okay, let me just open my file first. Okay, this is another demo. Okay, this is the demo for classification. Classifications, which means that this is a use case implementation of logistic regression. Okay, what is the example here is we want to base on the patient's data, okay, to predict whether that patient have diabetes or not. Okay, these are medical cases, medical applications. So which means that we want to base on the patient, whether it's pregnant, what is the value of glucose, BP, skin, insulin, so on and so forth. Based on this result, okay, we want to determine, we want to classify, okay, using logistic regression to classify whether the patient have diabetes or not. Okay, just for example. Okay, this is a classification problem because it's classified, want to classify diabetes or no diabetes, yes or no, something like that. Okay, because from here you can see that it's not to predict a number, it's to classify which class they are belongs to. Okay, so let me just do a quick one. Okay, so first of all, again, import the library. Okay, after import a library, second is to load the data set. So this data set have the input, have the data of how many times this patient has been pregnant, what's glucose level, BP level, skin, so on and so forth. Okay, and the label here. Okay, the label at the end of this data, 1 is mean have diabetes, 0 means no. Okay, you can see they are all become a numbers already, numerical numbers. Okay, these are the data we have. Okay, and then these are some data visualization. So from this data visualization, right? Okay, why this is also called an important step is because we have a lot of data. 1, 2, 3, 4, 5, 6, 7, 8 data. Okay, are they have relationship with each other or not? Sometimes too many input also not a good things. You must know, must have ability to remove those is not relevant. Okay, like I say, bad data lead to bad result, right? So you must know that which one is important, which one is not. So from here, you can use some methods to actually visualize data. Okay, from this is one of the method, okay, to see what's a heat map. Okay, just to display the heat map. So the lighter the color, these data have strong relationship with each other. The darker the color, they have no relationship with each other. Okay, so from here, you can see there's some lighter color here. So maybe that one have strong relationship so that we can pick those data to do the prediction. Okay, so this example, this is the data visualization. Then from the data visualization here, we have 8 data, right? We have 8 inputs, but at the end, we only pick pregnancy, glucose, PMD, and age. These are most likely will lead to better result based on this data visualization. So I pick these 4 as the input. Okay, I pick these 4 as the input. Okay, so pregnant, glucose, BMI, and age. So these are the data I want use for training. Okay, so after that, I prepare my X, which is the training data. So this is my X, the training data. So only have 4 columns of them. Okay, and then I split it into train and test set as well. So again, I'm also using 75% of training, 25% of testing. So for this case, for this data set, it actually have a total of 768. Total data in this data set is 768. So for this case, 75% is used for training, which is 576 of them. Okay, with 4 columns, 4 data only, 4 columns only, which is pregnancy, glucose, BMD, and age. So that's why you have 4 columns only. And then we have 192, 25% is used for testing. Okay, after that, I start to import the logistic regressions. Okay, and start to train the data. After data has been trained, then I start to predict. Okay, from here you can see when you do prediction, right, it will be in numerical number. So from here you can see that this is the true value. This is the value, this is true value from the data set. This is a predicted value. It's a prediction. From here, they are quite aligned with each other, which means that they based on that input, the 4 input, pregnancy, BMD, age, and also what else? And also the glucose. Okay, so from that is actually is diabetes. So based on this input, the model also can predict the correct. Also correctly predicted based on that input, the model actually correctly predicted. Okay, so you can see that most of them, they are correctly predicted. Okay, This one I just display the first 25 data. I mean, first 25 predictions. Okay, so you can see there's some wrong predictions here. There's some wrong predictions. Okay, so this just show the first 25 data. Okay, so from here you can use the metrics, which is the accuracy. Okay, just calling some function. So for this case, it's just okay only. The model accuracy is just okay. It's about 78% correct. Okay, accuracy is about 78% correct. So for this one, I say it's just okay, it's average only. But it's really you want to use this for medical purpose, right? This is not good, okay? Because for medical, you want to have a very good prediction, very good accuracy. So you must somehow fine-tune some parameters so that you want to increase this accuracy so that it can have a better predictions the next time you do the predictions. Okay, so that's some examples for the classification. This example for the classifications. Okay, so I actually finished my slide already. So any questions? Any questions? Anything you
Yes.
want to ask
Yes,
for
yes.
this
Hello.
workshop? Anything want to ask?
Yeah, can you hear me?
Yes.
Okay, thank you for your explanation and the concept. I have a few questions to ask Dr. Teoh. So the first question is, how have the LMS have been applied to the education over the past 5 years? And what has been their impact? And then what are your thoughts on their features, applications, and potential in this area? So now I pass back to the floor to the Dr. Teoh first.
So you're asking that how the AI model has been applied in education, is it? The first question. Okay, how does
in last 5 years?
last 5 years actually
Yes.
okay, how they apply in educations. First of all, the apply application, usually we will use this large language model, right? If it's academic stuff, right, we usually use it to like we really want to apply its use to for example proofreading. Okay, proofreading, because large language model is very good in text generations. So we will actually use apply in education mainly for proofreading. That's one of them. Also, if it's some applications, right, we are actually using use some API to actually use in some applications to so that you can actually ask the ChatGPT to give in some results so they can actually produce some result for the applications. And then sorry, what's the third and fourth questions?
But last 5 years, you don't have any ChatGPT yet.
Last 5 years,
Yeah.
not really, because this ChatGPT only come out in 2022.
Yes.
Yeah. Maybe I don't have answer for this. Maybe in the afternoon, maybe Dr. Alex will have answer for that. Yeah.
Okay. So what are the thoughts on your features, application, and potential for this area?
Okay. What are my thoughts? I would say that it's a very good model. Okay. It actually, before I exposed to LM and after exposed to LM, right, it actually just like I mentioned, one of the advantage, it can actually reduce my labor and increase my productivity. Some of the things that I don't need to like crack a lot of time. I mean, use a lot of time to generate the simple things that I want. So which means that you can use the ChatGPT to like I mean, any GPT models can give you some ideas, the rough ideas. From there, you can start to I mean, it can give you some brainstorming ideas. So from there, you as experienced staff, you can know that whether the result given by the GPT, whether it's useful or not. Then you no need to start from scratch. I can say no need to start from scratch because they already give you some ideas. You can actually start from there, then can move faster if you're using GPT. It can increase your productivity. You also can reduce some labor costs as well. That's my thought for LM.
Okay. So the next question is how can primary or high school or college or university learner effectively learn about the LMS?
Effectively learn about the LM
Yeah.
in terms of usage, is it?
Yeah.
Okay. Okay. If you want to effectively learn or use LLM, right? I think is how to say, you can increase your learning rate by using LLM. Some things that you some of the things that you want to refer, some things you want to refer. Okay. Most of the time you can refer from the textbook. That's one thing. Okay. Other than textbook, you can actually use LLM to increase your learning rate. Some of the things that is not really mentioned in textbook, but sometimes if you ask the correct questions and ask the LLM to, if you ask the correct questions and try to narrow down the question, then the LLM can give you a very good ideas and good result. Okay, something that the textbook didn't give you. You can learn something extra. You can increase your learning rate. So if the secondary school or primary school want to make use of this LLM, that's the best way.
So what type of teaching method that will be implemented to the primary school or high school students?
Sorry, what is the methods? Is it
Yeah, teaching method.
teaching methods?
Yeah. Because our education minister have been implemented asking us to use for the AI. So now we need to how to implement for the teaching method.
Okay, how to implement for teaching methods. Okay, if it's really want to implement into the teaching methods, if it's like want to learn AI, okay. So of course, there are few knowledge you must know. First of all, if it's just like surface, don't want to do any programming, it's fine. You can just use some learn some mathematics. Mathematics, you must have some skill first before you can actually implement the AI into the teaching. First of all, the mathematics. Okay, mathematics, because AI will use a lot of mathematics. So how do you teach? Because sometimes the mathematics can be very complex. Okay, it can be very complex. So you as a educator, how do you generalize so that the students can know how to simplify the mathematics formula so that students can understand well? And next thing is, if you want to implement AI, and then programming skill, you also must learn already so that student can learn very well. Okay, so these are the steps that you can start now. Okay, so programming and also mathematics. Yeah, something like that.
Okay. So the next question is discuss their impact on nature LMS and potential challenge to be addressed on their development and
Sorry, address
development.
the potential of LLM.
Yeah. Discuss their impact LMS and the potential challenges to be addressed on their development.
Okay. Impact of LLM, address the impact of LLM and how they sorry, let me think.
Yeah, you can educations. So now we are in education field, so you can implement in the educations.
Okay. I think I'm sorry, I don't have answer for that. Yeah, because how to say, maybe you ask, maybe you repeat the question again. Maybe I didn't get some of them.
我是讲是关于到我们可以讨论到自然的那个，刚才你说NS 嘛，是吗？它有在那个人工的那个智能的影响，然后你可以在这样的好像展延还是开发在它的那个某个部分，或者是解决的方法，或者是挑战。
Okay. .我思考过了，不好意思，我没有这方面的answer 给你，不好意思。
那好的，谢谢你
好，不好意思，谢谢。 还是如果你能的话，你也是可以，等下我说给你我 email，你可以 post 那个 question 给我，我再找比较实际的 answer 后我可以再回答你。
可以可以，好的，谢谢你，
这个是
Dr.
我
Teoh。
的email 了，OK 这边你可以 email 我过后，我再找你要的，我会在访问过后我再给你，这是我的
可以，
email。
好，
好
很好，
，OK
谢谢你
OK。
，Dr. Teoh。拜。
Any other questions？有什么问题想问的吗？你可以问华语问，还是用英文问都可以。学生们还是老师
老师，那我们要做什么东西吗？
？Have other questions？ Do we have to do any exercise? For this workshop, not really need to do any exercise. Okay. Then how to data mining and analysis for the preparation of data set. Okay, data mining and data preparation is one of the knowledge also to prepare the data set. For example, if you have a data set that have a lot of numbers inside, just for example, let me teach you. Let me just show you. Okay, so for example, data preparation, this is a good data set, which means that all the columns already have numbers, but some of them, they are not numbers, for example, like this. Okay, they are not numbers. Okay, so which means that you must prepare. Okay, some of the expertise, they actually use it to prepare so that you need to scan through which one that don't have number, then maybe they need to replace it with something else. If you train with something like this, your model wouldn't have any good result because there's some things that is not in number. Okay, so data mining and analysis. Okay, data mining and analysis is something for like you have a lot of data here. Okay, data mining can use some formulas to give you some result. For example, TV for this case. Okay, what is the average? Okay, what is the average? What is the highest value and what is the lowest value that you invest in TV? Something like that. It can give you some this kind of analysis. Okay, any other questions?
Okay.
Again, if you don't have a question now, maybe you have it later, you can always email me. This is my email. Okay, you can always email me. Okay, so if someone have any 如果没有其他 question 的话，是否我刚才在外面所以你 back to 你了。
对，OK，谢谢我们的 Dr. Teoh 然后非常精彩的那个整个我们的 workshop。那我们今天的早上 section 就到这里，如果有任何问题的话，可以联络Dr. Teoh 或者联络主办方哦。我们会收集相关的问题再统一公布啦。那接下来的下午的 section 就会在1点开始。那我会按这个 Zoom meeting 前，等一下1点的时候，我会在12点半的时候，我会再开放回去。OK， 好，
好，谢谢大家。
OK， 谢谢大家。
哎。
OK，Thank you。